what are the laws of indices? Well, the laws of indices are rules that allow us to simplify expressions with powers of the same base. Now, what do I mean by that? Let's get right into it. Here we've got a to the m times a to the n, same base, a. So our first law is that when we multiply them, we're going to add the powers. So we'll get a to the m plus n. Let's provide an example. So let's say 2 to the power of 3 times 2 to the power of 2. Now what does that actually mean? It's just 2 times 2 times 2 times 2 times 2. Let's just write all of that out. So like that. And you'll notice that we have 5 2's, which means that that is equal to 2 to the 5. Well, that was quick, wasn't it? Moving on, when we divide them, we're going to subtract the powers. Who could have guessed that? A to the m minus n. It's very similar in the sense that we can write this out like 2 to the 5 over 2 to the 2. This would just be 2 times 2 times 2, yep, over 2 times 2. And then we can just cancel out 2 of the 2's, and we're left with 2 to the 3. Straightforward. Now, when we've got brackets and a power outside of it, we're going to multiply the powers together. So we'll get a to the m times n. Because, say if we had 2 to the 2 to the power of 3, that would just be like saying 2 to the 2 times itself 3 times. And using our law from before, we know that all we have to do is just add up the powers, and then we would get 2 to the 6. And then an interesting one, anything to the power of 0 is equal to 1. That's a little bit confusing, isn't it? Well, if I provided an example, maybe it would be a little less confusing. Let's say we had 2 to the 2 over 2 to the 2. Well, anything divided by itself gives 1, right? The thing is that we can write 2 to the 2 over 2 to the 2 as this. And we know from our previous law that when we divide two terms with the same base, we can just subtract the powers. And, well, that would be 2 to the 2 minus 2. And, well, that's just 2 to the 0. But we just said that 2 to the 2 divided by 2 to the 2 is equal to 1. So therefore they must be the same thing in order to make the laws consistent with each other. And then we've got a very easy one. Anything to the power of 1 is just itself, because, well, you've just got one of it after all. And then when you've got a negative power, you're going to get the reciprocal of it, where the power is now positive. And what I mean by that is that you'll get 1 over the base with the negative removed, so it's just 1 over a to the m. This is a little bit weird, but let me provide an example again. Say we've got a to the 2 over a to the 5. Now again, when we divide, we're going to subtract the powers. So we get a to the minus 3. We can also write this as a big fraction. Who would have guessed? Now we can cancel out our a's, and that would give us 1 over a to the 3, which follows our rule. Now we've got when our power is a fraction, so what this does is that it gets the nth root of a to the power of m, which would be written as this. Now you can also write it as this, but I personally prefer the top one. Let me just give an example to show how this works. So say we've got 8 to the power of 2 over 3. Following our rule, we'll just cube root 8 and square it. What's the cube root of 8? Well, that's just 2. And then we can just square it to get 4. Nice, nice and simplified. And that's actually all of the laws of indices. As far as I've put down. If I missed one, that would be embarrassing, but I hope not. Also note that when you apply an exponent to a fraction, it applies equally to both the numerator and denominator. Let me just add that quickly. So a over b to the n would be equal to a to the power of n over b to the power of n. And that'd be the same thing for these kinds of fractional powers too. Well, let's get right into the questions. Hope you're ready. So we've got fractional power first. What we can do is, as I just said, apply our power to the numerator and denominator. So we would have the cube root of 8 to the power of 4 over the cube root of 27 to the power of 4 as well. The cube root of 8 is 2, and then we just raise it to the power of 4. The cube root of 27 is 3. Then we just raise it to 4 as well. And that would become 2, 4, 8, 16 over 3, 9, 27, 81. And that's it, yeah. Not too hard, is it? Alright, so we've got a power outside of our brackets. So we're going to multiply the powers. But here, make sure that you are raising the power of the coefficient as well to the power of 4, because that's like saying 3x to the power of 5, y to the power of 6 times itself 4 times. So we would get 3 to the power of 4 times x to the 5, 4 times y to the 6, 4, which would become 81 x to the power of 20, y to the power of 24. Nice. And for our last question of the lesson, that's crazy. I feel like this hasn't even begun. It's gone by so quick. We've got a question that's a little bit harder. I mean, I think there's a lot of people that would consider this to be on the harder side of things, because we have terms with different bases. So what we want to do is get all of the terms into the same base. And I'm noticing that all of them are powers of 3, so I can just write them as powers of 3. So let's do that. 9 is equal to 3 to the power of 2, and then I can just write it in brackets to the power of negative half. Then this is equal to 3 to the power of 3, and the same thing, write it in brackets, divided by 3 to the x plus 1. Now this is going to be a lot more simple to work with, because we can just apply our laws of indices, multiply the powers outside the brackets to get 3 to the minus 1 equals 3 to the 3 over 4 divided by 3 to the x plus 1. And now you'll notice that all of them are in the same base. A neat little trick is that we can just drag all the powers down, because we know that we're working with the same base. And what the question is actually asking us is to find the value of x. Since 3 to the minus 1 is equal to 3 to the power of 3 over 4 divided by 3 to the x plus 1, this must mean that minus 1 is equal to 3 over 4 minus x plus 1. And make sure that we write x plus 1 in brackets, because we're dividing. So we're going to subtract the entirety of the power. Otherwise, we'll get the question wrong. So minus 1 is equal to 3 over 4 minus x minus 1. Let's just do a little bit of shifting around, and we'll get this. The minus 1s cancel out, so x must equal to 3 over 4. Nice! I think that's 3 marks well deserved. Well, that was a quick lesson, wasn't it? Laws of indices may be short, but very important. So, don't miss out on practice, Radiant Scholars.